Tony, really appreciate for joining us today. Tell us a bit about your background and expertise and your career highlights, Tony.
Yeah, g'day guys. Tony Tang. So I'm Chinese Vietnamese born. Came to Australia in the 80s and study high school at Perth Modern and Manly Senior High. Went to Curtin University, study and have a bachelor degree science there, major in chemistry and metallurgy. So I've been working in the industry, in mining industry sector since I was at uni, and the area that I've been focused on the last 25 plus year is in hydromet, like nickel, cobalt, manganese, rare earth, gold, yeah, all the critical mineral that we are currently working on them. And my highlight of my career would be when I first came out, I worked a real project called Marmaran. It has many challenges. It's where we're producing 40,000 ton of nickel and in the briquette form. It was a second generation high pressure acid leach. So I was there during the test work in the commercial lab, and then lead all the way to gone on site, part of the construction completion, commissioning, operation, troubleshooting, research development. That's where I start involved in the nickel metahydride technology. For those who remember, nickel cadmium was the first rechargeable battery, and then came to nickel metahydride when you don't have as much issue and the memory issues, and then lead to lithium battery in the late 2000. So that was one of the highlight in the nickel. Then I got involved in many technology development for the nickel process. When I left Marmaran, after nearly 10 years there, joined engineering firm and trying to help out a few projects around the world with my what I have learned from Marmaran, but didn't eventuate. So I was involved with Boddington gold mine expansion, Newmont and Boddington. That was a 35 million ton gold project, was the biggest Southern Hemisphere gold project at the time in 2007 to 2010. I was involved in that. I was one of the lead members there. So involved in the design, EPCM, went to site during the construction completion again. And it was a very quick ramped up project. So we produced, the nameplate pretty early on, and that was my highlight on the large mega project for gold. So after that, I was involved a number of rare earth projects like Arafura, Hastings, IAMGold, Renoir. Got really involved in those projects at the early days. Built a few pilot demonstration plan for the rare earth to separate all the rare earth elements, especially the heavy rare earth at the time was good values. So that was a very interesting and to me it was a highlight because I go from hydromet in nickel, cobalt, and then I went to gold and copper, and then to rare earth. And during that time also I was involved in the direct nickel process. There was a founder, the gentleman named Bill Drinker from Canada, and he had this process and helping him since 2008. And then I was involved in that particular project at CSIRO. We built a pilot plant there. I was involved. So we using direct nickel process using nitric acid, and you can regenerate all the reagent. And that was a very exciting project. Because of the nickel price went really low in 2012, 13, 14. So the project was not economic at the time and was shelved. but now that technology is getting used by Queensland Pacific Metal. So that's a good thing. Then I was involved down to recent one is Taliesin and TNG. So in roughly about 2017, lithium became so hot. So I was very happy to get involved with that project, and went and worked on that project, EPCM under MSP engineering house. So deliver the CGP2 down in Taliesin and LHPP 1 and 2. So after that, I went to do a couple of interesting projects using renewable technology that we call high temperature pyrolysis. Is treating all the rubbish, the plastic, wood waste, tire waste into biochar and syngas, and using gas to enriching the gas for the gas pipeline, and also using syngas to generate electricity. So that was very exciting. So it was 2 projects in Australia, 1 project in Belgium, 1 project in Spain. After that, I didn't get a chance to see it eventuate, because I moved on to Blackstone Mineral, which is where I get a chance to work on a unique project in Vietnam, location called Sơn La, because to me it is a very important project for the Vietnamese. That's where I was born, so I thought it would be good for me to touch base with where my country birth. So John Blackstone helped develop the flow sheet from the ore to concentrate all the way to precursor. So during that time, I was very fortunate to get involved with future battery, CRC, to do various innovation there. And now I'm end up at Chemical X, so ChemX Material, where we focus on HPA, manganese, and potentially rare earth and kaolin. So that's the highlight of my own career.
Thanks, Tony. That's a very diverse background. And I think, just focusing on sort of your battery metals experience, you've been in the industry for a long time. So I'm curious to understand, over the last 10, 15, 20 years, has the industry actually played out as you expected? Obviously, it's gaining a lot of momentum now, but any surprises? How have you seen it evolve compared to your expectations?
Well, all the material that I just mentioned, it has been, exceeding expectation. It was unexpected. It was more faster than a lot of people anticipate. All thanks to Elon Musk. He's created this electrification movement to electrifying. So from that point, and same as China, they was the front end leader to convert all their fossil fuel combustion engine to electric engine, and so the demand is exponential, and the skill set is the limit, the resource is the limit, and so people have to be very cautious and be very responsible. We don't have endless resource. It is finesse and it's defined, so we need to be mining and processing and use it in a sustainable way. But yes, it is exceeding my expectation. It was just too fast.
That's interesting.
Fantastic. Thanks for that. So tell us about your more recent initiative, including your collaboration with Curtin University and also Future Battery Industries, Tony.
Yeah. So I've always been an advocate of giving back to the industry. So I always partake in the high research degree student, like PhD candidates and master's candidates and postdoctorate candidates. Working with them is provide them the industry taste and experience what we're looking for and how relevant of their research and work can be immediately applied and utilized, giving that interface and linkage to them. So for me, it has been an honor to serve in the university. So I've been a senior research fellow at Curtin and work with Future Battery. So managing the team there with the precursor plant, they have a very fully automated precursor plant with so many participants. So I'm recently appointed there on part-time is to manage the operation to ensure that the technology and the operation can be smoothly operate. With the research, we're doing so many things. We're talking about pyrolysis, we're talking about critical mineral rare earth extraction technology, how to extract mineral from ore in a very environmental friendly way. As you all have heard about the glycine technology and how we can improve the hydrogen process. The hydrogen electrodialysis is very energy intense, and the cost of the material for the electrode are very expensive. So to commercialize it, to make the whole process and technology is affordable and sustainable, we have a team there. Basically every single day is find a good substitute or alternative material to bring the cost down in order for the technology can be viable and affordable for everybody. So it has been a many breakthrough with the student. Curtin now on a few patents on the technology, and yeah, hopefully these will be soon available for commercialization.
So, Tony, do you think then, with obviously your work is feeding into this next question, do you think that Australia can actually become a downstream processing hub, and can we compete with the rest of the world on a cost competitive basis?
For me personally, I believe yes, we can. Why? For me, when you look at the carbon footprint, most of the resources are coming from Australia at the moment. We're supplying high percentage of resource globally, and especially most of our resources at the moment go to China as their feedstock: rare earth, nickel, cobalt, manganese, graphite, lithium, copper, and so on. So it is expensive for us because we have high labor. However, the technology is improving with the driving of carbon analysis. We find better way to processing it, and that's why I involved with university and involved with the stakeholder like the vendors, how we improve the technology and how we using the synergy of chemical regeneration, equipment, energy, conservation, bringing down the cost of the processing. Yes, I do believe it is possible when we have all the wills from the people and the government commitment, because most of the people that I have worked in the past, really experienced people and students, graduate from PhD, they found Australia didn't provide the challenge that they wanted, and then they moved back to Korea, moved back to China, moved back to Taiwan, moved back to Germany, and then all moved to United States to use their skill and new challenges. So if Australia embraced these smart people and also new technology, of course we can go all the way to battery and make the battery become affordable. It is challenging when you start one, but it can be done. It just, when you see the less waste in between. Every single time we stop the process, and then we package it and we sending it, and then we send to another country, they unpackaging it and then reprocessing it. When you look at all that whole disruption, the cost actually not that expensive in Australia. But because
Yeah.
it's just the labor, so we have to using more smart technology, you use more renewable energy. We have such a large sun and wind renewable energy. We should harvesting that and tap into it.
And
I think
Tony, do you see a lot of support from federal and state governments coming through?
Yes. So they getting it. They are getting it. Now it's about having the right people, like FEICRC, the trailblazers, the critical mineral. The government have set up a lot of champion organization to start attacking this. Now we need not just the government, but we need the industry who believe in this. So we have BHP, we have IGO, we have TNG, we have all these companies. We all come together as a cooperative research center, and we trying to make this work. Once this one work, it takes each state to commit into it, and it will happen.
Okay, Tony, I'm just wondering, out of curiosity, in terms of the movement towards the electrification of transport, do you see a particular metal that might benefit the most in terms of a demand increase?
I see all of them playing equally. They all have their strengths and weaknesses, and for us, we need to use it in the best optimum use. Some is good for fast charging and high power throughput, and that's ideally for uh, um, industrial electrification like truck and so on. But normal domestic, you can using a less expensive material and still fit for purpose, still doing the job right, and still give you a good range, good charging rate. So there are so many chemistry in there that we can work with, and we can make it work for the project and for the electrification. I just that people at the moment just want to see how far they can push it. But like China, the lithium iron phosphate, the technology has improved and they're increasing the ranging and so on. And now they start additive to it and changing a cheaper chemical material into it and make it more affordable, bring the cost down. Unless the cost is coming down, the electrification is becoming extremely challenging. And that's why research and company like BYD, CATL, POSCO, LG, they working on chemistry, and BASF, they work on new chemistry constantly. University student that PhD candidates are working with me. We constantly changing the chemistry to make sure that we substitute to producing the battery chemistry fit for purpose per application.
So in terms of the work that you're doing at ChemX, then it looks like you're focusing a bit on the manganese. So what kind of role do you see manganese then playing in the battery? Is it going to gain further adoption?
Absolutely. Manganese is amazing. A lot of people don't realizing it. Manganese has the electron. If you look into the chemistry, the electron, you got a 2+, you can go to the 4+, you can go to, so it has multiple electron component into it. If you learn how to stabilize it, you secure that, you're improving the electron and so on. Manganese has been used in the battery for a long time. In the past, has been using for disposable battery, and the oxide battery, and the lithium manganese oxide has been using power tool medical equipment for a long time now. And now we start looking into the manganese is like the nickel manganese component, the lithium manganese iron battery component. It's just improving different chemistry for different application. and different uses.
Thanks, Tony. What kind of role do you see green hydrogen playing in the next, say, 10 to 20 years?
Oh, huge. Hydrogen is so important. A lot of people might have some reservation with it, but the right process, the right technology, especially using green technology, using sustainable material to crack the water, and using the power and how we're storing it. If we do that successfully in a very economic way, bring the unit cost down, it has so much potential. It's amazing. Like even they're using hydrogen in the diesel engine. One of the university research group in New South Wales recently, by having some enriched hydrogen into their system, you improving the combustion and you improving the energy and you reduce the use of diesel. So all these things are important. It's just that we need to improve the technology to producing the hydrogen greener and more economic for many applications.
And Tony, what new technologies or developments in the mining and battery metal space should we be looking out for in the next, say, 5 to 10 years?
The way we're processing it is improving. So we're looking into the mining, learn how to mining more sustainably. The full life cycle, like circular economy. So basically reuse and maximize what you mine and recovering. So sometimes you might look into one or two mineral, a chemical in the mineral and to extract and then you discharge. But if you're looking into partnership with someone next door who has a different process for your waste, then you improving that waste into someone else's product. That is to me is important because that is how we should be using the resource is maximize. Because when you mine already, it's already cost. When you extract it already, there's already the cost. It just work together. So that's what we see in Kwinana right now. We have TNG, we have IGO, we have Nickel West, we got Alcoa, we got Coogee Chemical. They all work together there. Everything is in one central area, and basically they can process and supply in a very collaborative way, make the whole process quite economic and workable.
I know that every metal has a different property. It has different properties. Every ore body is unique. But I'm interested to know, in your experience, what do you consider to be the most difficult metal that you've worked in?
Rare earth. That's why it's rare earth. Rare earth is very challenging to process because they are the reason that we saw them rare, but they're not so rare. They're abundant in the world, but they come in a very small concentration in the ore, in the mineral. So normally it's you need to chemically extract all the other mineral first before you can extract rare earth, and that's where the cost is so high because of that reason.
And is there a particular project perhaps that you sort of touched on Murrin? Is there a particular project that you'd like to mention that maybe had its biggest challenges and how you overcame them?
I would say well, they no longer exist. One of them was Hastings in the Brockman project in northern of Western Australia, but that project is not now that deposit is put on hold, but they work on a different tenement because it has high aluminium content, and that was a very challenging. But now with alumina and HPA, that project might have a chance.
Great. Thanks, Tony.
That come on our podcast. What's one thing that excites you the most? It can be about the future that's going to happen in the next, say, 5 to 10 years. And also what's one thing that frightens you the most?
The most exciting thing to me is the evolution of chemistry of the battery, and what we can do, with our is smart people. That's exciting me every day. I look forward to meet my PhD candidates and research team is to share what possibility, and what afraid me the most is we are looks very short term, um, of doing things, and we don't do it in a very sustainable way. Especially I just mentioned about circular economy. Lots of people, they take one or two component out and then they forgot about the rest. I grew up in the environment that I believe if you can utilize as far as you possibly can and economically can, we should try.
Thanks, Tony. Really appreciate your insights today. It's a pleasure to have had you on our show. So hopefully, yeah, we can stay in touch.
Absolutely. Well, hopefully very soon. Take care,
Thank you.
guys.
Thank you.
Thanks for having me. Cheers.